Sensory perception. Thursday, May 14, 2020. 8:13 p.m. Sensory perception.
Visual cues. Depth, form, motion, constancy. Binocular cues. Retinal disparity, eyes are 2.5 inches apart. Convergence, things far away, eyes are relaxed. Things close to us, eyes contract. Monocular cues. Relative size, interposition, overlap, relative height, things higher are farther away, shading and contour, motion parallax, things farther away move slower. Constancy, our perception of object doesn't change even if it looks different on retina. X, size constancy, shape constancy, color constancy. Sensory adaptation. Hearing, inner ear muscle, higher noise equals contract. Touch, temperature receptors desensitized. Smell, desensitized to molecules. Proprioception, mice raised upside down would accommodate over time, and flip it over. Sight down, X, light adaptation, pupils constrict, rods and cones become desensitized to light, and upregulation, dark adaptation, pupils dilate. Weber's law. 2 versus 2.05 pounds weight feel the same. 2 versus 2.2 pounds weight difference would be noticeable. The threshold at which you're able to notice a change in any sensation is the just noticeable difference, JND. So now take 5 pounds weight, in this case if you replace by 5.2 weight, might not be noticeable. But if you take a 5.5 pounds it is noticeable. I equals intensity of stimulus, 2 or 5 pounds, delta I equals JND, 0.2 or 0.5. Weber's law is delta I to intensity is constant, x. 2 halves equals 0.5/5 equals 0.1. Delta I/I equals k, Weber's law. If we take Weber's law and rearrange it, we can see that it predicts a linear relationship bet. Wien incremental threshold and background intensity. Delta I equals IC. If you plot I against delta I, it's constant. Absolute threshold of sensation. The minimum intensity of stimulus needed to detect a particular stimulus 50% of the time. At low levels of stimulus, some subjects can detect and some can't. Also differences in an individual. Not the same as the difference threshold, JND, that's the smallest difference that can be detected 50% of the time. Absolute threshold can be influenced by a number of factors, X psychological states. Expectations. Experience, how familiar you are with it. Motivation. Alertness. Subliminal stimuli, stimuli below the absolute threshold. The vestibular system. Balance and spatial orientation. Focus on inner ear, in particular the semicircular canals posterior, lateral, and anterior. Canal is filled with endolymph, and causes it to shift allows us to detect what direction our head is moving in, and the strength of rotation. Otolithic organs, utricle and saccule, help us to detect linear acceleration and head positioning. In these are Ca crystals attached to hair cells in viscous gel. If we go from lying down to standing up, they move and pull on hair cells which triggers AP. Also contribute to dizziness and vertigo. Endolymph doesn't stop spinning the same time as we do, so it continues moving and indicates to brain we're still moving even when we've stopped, results in feeling of dizziness. Signal detection theory. Looks at how we make decision under conditions of uncertainty, discerning between important stimuli and unimportant noise. At what point can we detect a signal? Origins in radar. Is signal a small fish versus large whale? Its role in psychology, which words on second list were present on first list? Real-world example, traffic lights. Signal is present or absent, red. Strength of a signal is variable D, and C is strategy. D, hit, miss, strong signal, miss, hit, weak signal. C, 2 strategies, conservative, always say no unless 100% sure signal is present. Bad thing is might get some misses. Or liberal, always say yes, even if get false alarms. For any signal, have noise distribution. And get a second graph the signal distribution. The difference between means of the two is D. So if signal shifted to right, D would be big and easy to detect. If left, D very small and more difficult to detect. X-axis have intensity. The strategy C can be expressed via choice of threshold, what threshold individual deems as necessary for them to say Y versus N, X, B, D, C, beta, just diff variables. If we were to use B, let's say choose this threshold 2. So anything greater than 2 will say Y2, anything less say N. So probability of hit is shaded yellow, and false alarm is pink. D equals dB, so let's say D in this example is 1, so 2 minus 1 is equal to 1. So if we use D strategy, anything above 1 equals Y. C strategy is an ideal observer. Minimizes miss and false alarm. C equals BD/2. So in our example, it's 2, 1/2 equals 1.5. So anything above a 1.5. When C equals 0, participant is ideal observer. If 1, liberal. If 1, conservative. Beta, set value of threshold equals to the ratio of height of signal distribution to height of noise distribution. Beta equals D, X C is equal to 1 times 1.5 equals 1.5. Bottom-up versus top-down processing. Bottom-up, stimulus influences our perception. Processing sensory information as it is coming in, built from smallest piece of sensory information. Top-down, background knowledge influences perception. X. Where's Waldo? Driven by cognition, brain applies what it knows, and what it expects to perceive and fill in blanks. Gestalt principles. Similarity items similar to one another grouped together. Pragnance reality is often organized reduced to simplest form possible, X Olympic rings. Proximity objects that are close are grouped together. Continuity lines are seen as following the smoothest path. Closure objects grouped together are seen as a whole.